Okay, for the last question in part 3, number 36, we have a piecewise, we have a system of equations that involves a piecewise function. So this was a complex looking graph here. Let's start with the easy function here of g of x. So we're going to graph both of these, and also it ultimately asks us just simply how many times do they intersect, or how many times does f of x equal g of x. So we don't even have to find the intersection point, just how many times they do intersect. Let's start with g of x. We'll get the easy one down first, and then we'll dive into the piecewise. So for g of x, which I'll do in red, we have a y-intercept of 1. It's already in y form, or g of x form here. I'm going to plot 1 on the y-axis, and since my slope is 1/2, I'm going to go up 1 over 2, and so forth. We don't know how far these graphs are going to have to go to intersect one another, so it can't hurt to overextend this line here. That's g of x. That was relatively easy. Now for f of x, we have a piecewise. So we're going to split this up. I teach piecewise by doing the different rules into different tables. I'm just going to separate them on the left and right here. So let's start with the first component. I'll erase this once we're done with it. The 2x plus 1 rule. This only works when x is less than or equal to -1. So we want -1 itself and a few values less than that. It's only going to be a line, so I only need a few points. At -1, we can also represent what type of circle it's going to be as a little reminder. How do I know it's going to be a closed or filled in circle? It's because it was less than or equal to -1. So since it can equal -1, I want to represent that graphically when I ultimately get to that, with a filled in circle. Okay, my y values that can come from my table are -1, -3, and -5. You want to be careful with using m and b with piecewise functions because we're not actually plotting the y-intercept here. So table is a little bit easier, which is why I teach it that way. So at -1, -1, a closed or filled in circle, -2, -3, -3, -5, we should start to see our line. And this is going to continue forever. There was no lower limit. It just said x has to be less than or equal to -1, so we put an arrow on that left-hand side. Okay. Now for the second rule, we have a quadratic. So a little bit tougher here. Note that this cannot equal -1, but I'm still going to put -1 in my table. This is where some people get a little confused. So why am I putting -1 in there if it can't equal -1? First of all, I'm going to represent -1 with an open circle. So that's okay, as long as I do that. And why put it? Because otherwise, if we just start at 0, we're missing all of those values in between. -1/2, -0.2, all those values in between -1 and 0 that it could technically be that we'd be missing graphically if we didn't include it. So always include whatever this number is here. You're just basically looking to see whether it should be an open or a closed circle. The y values, once again, I can type into my calculator and pull them out that way. And similar to the line, you don't want to graph this the usual way. It's okay that it's not symmetric. In this case, it's actually pretty close. But just use the rule. Don't worry about doing it the way you usually graph a quadratic or anything like that. Just use the given rule to graph your curve or your line. So I'm going to plot -1, 1 with an open circle. Plot my rest of my points here. We see we're getting basically like 3/4 of a parabola. We got the vertex there, and we're looping around on the other side. And this is going to keep going. So on the left, I know it stops there at that open circle. But this is going to keep going. So I'm going to put an arrow on this side. Because again, x can be anything greater than -1, so it's going to keep going. 1, 2, 3, 4, and so forth. Okay, and that's my f of x in green. I had g of x in red. I want to label our two equations since this is a system. And the question on the bottom made it a little bit easy for us. It said, how many values of x satisfy f of x equal to g of x? So in other words, how many times are these two functions equal to each other? And explain how we know by referencing our graph. So these two functions are equal to each other exactly once. So how many values of x satisfy this? Just one. How do we know that? The graphs intersect only one time. It's not a clear intersection point, so it's nice that they didn't ask us that. The graphs intersect, sorry. exactly one time. And I'll highlight it here. You wouldn't have to do this, but they're intersecting right here. So at this point, f of x is equal to g of x, and they're not hitting anywhere else. If you extended maybe the left side of that parabola, maybe you could have put 2 by accident and made a mistake, but they should only intersect exactly once. So that's the answer to the question on the bottom there.